In this video, we are going to explore the rational function, and specifically, we are going to, or you will be able to graph the parent function and find the asymptotes. So let's take a look. All right, what we have is your parent rational? Well, if we look at our equation here, the equation f of x equal to 1 over x is what we call the rational parent function. So first off, we want to establish what does it mean to be a rational function. To be a rational function, let's come back and take a look at it. Notice where the x is. First of all, we have 1 over x, which makes this a fraction. We have a numerator and we have a denominator. And specifically in the denominator is where the x is located. So this is a rational function because we have an x in the denominator. So why is it rational? Written as a fraction, specifically in the denominator, we have our x. And that right there is why it is a rational function. Now let's come over and answer our next question here. Well, why is it the parent? Well, we have graphed throughout the year, we have graphed many parent functions, starting with our linear function, our quadratic, our absolute value, and then this semester we looked at the exponential and the log. So in all cases, they all had parent functions, and that was the function before we did any transformations on it. So why is this the parent function? It is the simplest, most basic function from which the other functions come. Or in other words, once we start transforming this, then we will see a variation. But remember, just like all our other functions, it will maintain the shape of the parent. So what we're going to do in this video is to establish what the parent does look like. And then once we establish that, we will establish the fact that this graph does in fact have asymptotes. It has two actually. It has horizontal asymptotes and vertical asymptotes, and which makes it very unique. And then we will see from our parent how we can actually see them visually, and then we will continue later and we will figure out how to find those asymptotes algebraically. So the first thing we're going to do is we're going to fill in our table right here of values. And what I want you to do is I want you to pause the video right now, and I want you to substitute all these values into your calculator, or if you can do it without the calculator, that is absolutely awesome. And then turn the video back on and see what you have. All right, hopefully you ended up with the same values for your table as I did. If you used the calculator and you tried to divide that 1 by that 0, you got something. Hopefully you got an error. And if you tried to do it without the calculator, I hope you couldn't come up with an answer because it is in fact an error. So let's go ahead and look at some of these values on the graph, on the coordinate plane, and then we will graph those in. Let's start at the top. Let's start with some of these over here. Let's start with the -1 gives us 1. We'll put that one in. Let's put in the -0.25 right here. That gives us a -4. So -0.25, I don't know, it's really close to the axis here. That's going to give us a -4. So I don't know, somewhere right along in here. And then let's do another one. Let's do a -5 right here on the edge. -5 is going to give us a -0.2. So we're really close to the axis here as well. So we've got 3 points here. And let's kind of look at what's going to happen. See that? You can go ahead and fill in those other ones too if you like, so you can see what's going on. I'm going to pop over here or down here to the positive values. So I know I'm going to be over here in quadrant 1 because everything's positive. So I'm going to graph that 1, 1. So let's plot that right there. And let's go out to the 5. The 5 is going to give us a 0.2. So just barely above right there. So how about right there? And then let's graph the 0.25, and that's going to give us a force of 0.25. I'm really close again to the y-axis here. And let's go up to the 4. Okay. So now let's graph these. Go ahead if you would like and put your other values in there so you can see what's going on. And if I plot these points, looks like I've got myself a little curve going over here in quadrant 1. And then over here, I've got another curve going on. Notice that we have no values in quadrant 2 and that we have no values in quadrant 4. So this is our parent function for our rational function. You see that, in fact, we have two separate curves, and we call these curves hyperbolas. You'll hear me refer to those as hyperbolas. And what we notice is, I hope that you are seeing, in fact, that when I plotted those points, you notice how I got really close. So let's look over here, how I got really close to that axis, but didn't get there. And also down here, when I graphed this point, I was close to the axis. And then over here in quadrant 1, you notice that these points I graphed were really close, but again, never touched. So what are you thinking? Are you thinking about asymptotes right about now? If we look at quadrant 1, remember our exponential decay. Remember how it went down and got really, really close to that x-axis, but it did not touch it. And I hope that you're seeing that occur here as well. So in fact, for our rational parent function, we do have, for its horizontal asymptote, the x-axis. So let's see if I can sketch that in. Let's get a color here. Let's see if I can sketch that. So for our axis here, so right here, we've got our asymptote. And see if I can come over here and get it over here. We've got our asymptote here. And then if we look at, let's take this point right here, you see how it's really close to the y-axis. And then if we come down here, when I plotted this point, you see how close it came to the y-axis. So I'm hoping that you can see, in fact, that we do have a vertical asymptote as well. And that vertical asymptote is the y-axis. Let me see if I can get that drawn in. Oops. And there it is. Not great. Sorry about that. Now, let's recall again what that asymptote is. Remember that that asymptote is that line that they're approaching, okay? But they are never reaching. So let's go ahead and fill that information in. Remember that the asymptote is that line that the graph is approaching as the x or y values become extremely large or small. And I hope you recall that when we were doing the log functions and equations, we pulled those calculators up and we saw how the calculator actually either blows up with just extremely small decimal numbers, or it just starts giving you errors and won't continue to graph. And so in this case, we have the asymptotes here on the x-axis. So this is our horizontal asymptote on the x-axis. And then up here, we have our asymptote on the y-axis. So where are the asymptotes? The x-axis. And for our equation, remember that is where y equals 0. Right? And then the y-axis, or as an equation, that is where our x equals 0. So here is our parent function. It's got a hyperbola in quadrant 1. Okay, so it's got that hyperbola here in quadrant 1, and it's got the hyperbola here in quadrant 2. And then the last thing we're going to talk about is the domain and the range. The domain and range are very important with our rational parent function, just like all the others, and that is because we do have two asymptotes, so we do have to establish those asymptotes from the get-go because we know that we have values that do not exist. For example, I'm going to come back up here to the parent, and remember what happened when we tried to sub in a 0. We know we cannot divide 1 by 0, and we get that error. So let's look at how it affects the domain. So I know in fact that my x cannot be equal to 0. We proved that over here in our table of values. So it affects the domain in such that, let's see. If we look at let's look at the x-axis, we see in fact that it is going to positive infinity. And we see over here that it is going to negative infinity. The only place it's not going, right, is the asymptote. So your domain are going to be all values except for 0. So for your domain, x cannot be equal to 0. And if we look at our range, so if we look at our range or our y values, well, we see that in fact it does continue to negative infinity here, and it does continue to positive infinity here. And we see that in fact your range or your y's can be all those values except right here on the x-axis. So for our domain, the x cannot be 0, just as well as the y cannot be 0. And if we wrote that out, we would say x is not equal to 0 and y is not equal to 0. So let's take a look at the three graphs below here. I'm going to do the first one, and I'm going to let you finish this up. So I'm going to look at my hyperbolas, and I'm going to try to pinpoint where I have my asymptotes. So I'm looking right here, and I can see really that this is just going to continue to go up and not touch this value here. And then I come down here, and I can see the same thing going. So I am just going to sketch in, best I can, my asymptote there. And that is a vertical line. So I know, in fact, that the x value there is 2, so my graph is x equals 2. And then I'm going to find my other asymptote. So I'm looking here. I can see that I'm getting close to the axis here. And then I come over to the other side. I can see that it's getting close here. So I can establish, in fact, that x-axis is my asymptote. Or in an equation form, we know that that's where y equals 0. All right, so I want you to come over here and finish these two up and bring those back to class along with your notes filled out.